Hello, everybody. I'm Michael Monaco.
And I'm Bobby Sal, and we are the Hazmat guys, bringing you knowledge and insight to make your job a little bit easier and safer.
Let's take a minute to hear about today's sponsors.
Hey guys, Bobby from the Hazmat guys here, and this episode is brought to you by FLIR Systems. If you're not sure about your white powder is fentanyl, or maybe you suspect that you have an explosive hazard, or you need to confirm that the leaking barrel is toxic, the FLIR Griffin G510 GCMS is your go-to for next level on-scene chemical identification. Mounted in your vehicle or carried to the point of sample collection, it is always ready. Using the built-in touchscreen, start the method wizard to help you select the best method for the mission. If you have no time, no lab, it's no problem. You can quickly identify unknown chemicals with accuracy. To learn more, go to FLIR.com/G510, or that's FLIR, FLIR.com/G510.
Let's get to the show.
Hey everybody, welcome back to episode 204, where we're continuing down our road of unknown, categorization, understanding.
Doing stuff with things we don't know about.
Yes. Yes, indeed. But before we get into that, like we do every show, we are going to be in Florida.
When? Mid-January, right?
We're going to be there. And also October 6th and 7th.
Yes, how could I forget about our very first Federal Resources class together?
Yes. And so we are going down there to hang out with the good people at Federal Resources to go through modular metering, a new concept that we've kind of brokered with them, and should be pretty good.
Yeah, we got a lot of people signing up and coming, so if you're around and if you're available and you still want to try, I think it might actually be closed out.
It might be.
But if you really want to, you could, take us out to dinner afterwards. We'll tell you what it was all about.
We're not shameful. We will take your beer. But also, we might even be debuting. I don't want to say debuting because it's the wrong term. We might be also giving a sneak extra Hazmat escape room while we're down there.
Yeah, I think we're going to have to do that. I think that might include some alcohol afterwards.
If you get a box, you take a shot.
Yes.
Could go very wrong.
So different. So many different ways.
And what else? What are going to be? We should definitely let people know is we are starting up the Hazmat Roundtable again.
Yes, I'm very excited about this. We are doing it the second Tuesday of every month, starting at 9 o'clock Eastern Standard Time.
Yep.
And the platform and the ways in which you will watch are still going to be announced. We're still working out the kinks.
What you do is go to the Hazmat Guys YouTube channel, our channel, and subscribe. That way you'll know. But I know it'll be coming up. We're probably going to open up the room a little bit early just to check levels and all that stuff before, because we know we're going to screw it up. We've been off the air for maybe 3 years doing this thing, so there's a little bit of logistics with the new format. If you were a watcher or a listener of it back 3 years ago when we DC'd it last time, but I think it's going to work out. Which our ultimate goal is to run it on Facebook, YouTube, Twitch, all these things simultaneously. So wherever you get your content, you can get us.
Right. Now, I'm not saying there will be. I'm not saying there won't be. But the very first time we did this, there were boobs.
Yes, there was.
So you got to come on to see if that'll happen again.
Yeah. And they weren't ours.
They weren't ours.
They were just random people signed in and just started flashing. They were, okay. Good times.
Yeah. So we are moving right along with the unknown chemical. This is our third episode, third in a series. We don't know whether there'll be a fourth. We're going to see if we get through all the stuff that we want to. But where did we leave off?
Well, we're still talking about assessments, right? So I'm pretty sure we're up to like the chemical area. Like we're looking at a chemical where we went through radiologicals.
Right.
And now we're going to talk about, let's say it's a chemical. So most of the other hazards that land under this chemical assessment, and just like most things that we want to take an approach of that, what can hurt us first and what can we gather before we even touch it, right? We want to use our sight. We want to see it from far away. So before we touch it, we move it. We change its state by, like, let's say opening a lid, or something like that, we want to do a good amount of observation. It is not a bad idea. And this is where the hazmat approach of slow down comes into it, because you can chalk it up under the more I observe, the more, I'm not going to say applicable my tactic will be, but the more probably it will be right.
Right,
move.
right. Well, now do you, and we talk about this in one of our lectures, the 70-30 rule.
Yes.
Do we kind of go along those lines with the 70-30 rule? For those of you that don't remember, the 70-30 rule is a military rule, and basically it says that if you are trying to gather more than 70% of the information before you make a decision, you've waited too long, and if you only have 30%, you haven't waited long enough.
Right, you don't have the information you need. And I would say in order to do hazmat mitigation, I would say it's probably more in the upper range.
Like a 65.
Yeah.
Yeah, you definitely want most of the information. And so we take this approach because we're talking about observations here, right? That's the first thing we do. So as we're approaching the scene, we're looking around. That state of matter is going to be one of the first things that we turn around and go, oh, okay, I'm dealing with A. And in this case, we're going to start to talk about solids. And as we talk about solids, let's keep in mind that even solids require SCBA. And there's a whole host of reasons for this, right? There are solids out there that will vaporize, and they will be in powder form, and things that are in powder form could very easily become airborne and stay in the air for a long, long time. So there are just a couple of different reasons why we want to make sure we always have the SCBA.
That's actually probably not done as much as it should be.
On a solid, definitely not. This is one of those do as I say, not as I do.
Yeah, it probably is. And you know what? Being that a solid can hurt us, there's a few ways that we can test to see if this solid is, let's say it's a bad boy.
Okay.
Right?
The very first one that I could think of, like if I'm going to sit and I'm going to go, all right, I'm going to try to do some testing on stuff, I think that's going to be mixing it with a little bit of water.
Yes. Okay.
Right? And this is going to show us a couple of different things, but one of the first things it's going to be able to show us is the solubility.
All right. So as far as the water, what all too often happens is, let me grab the sterile water off the EMS.
Ooh, that's pretty good. I was thinking hydrant water.
Hydrant water, yes. I'm sure it's clean as a whistle like it is where we work. But you want distilled water. Okay.
All right. What is the difference between distilled water and water that I get off the ambulance?
Okay, so the distilled water, well, let's start with this. Hydrant water, tap water, municipal water, they all have different minerals and stuff built into it.
Okay.
They might have a buffer where the pH is being brought back to neutral. It might be naturally one way or the other.
So more chemicals added to the mix.
Yes, and so there's more variability. If you add something to water that already has something, and that is an activator or a catalyst for a reaction, you might be getting a false reaction based upon that water. Now, you can get deionized water, but that's going way over the top for this crap, so we don't need that. Good distilled water comes 99 cents at Food Town, Stop Shop, whatever the hell you go to. And what we've been doing is you get a regular seltzer bottle, like a regular. You go to the 5 and dime. I don't even know if that's really a thing anymore. But you get just the Seagram's seltzer bottle, and when you're done with the seltzer, let it air out and then fill it up with distilled water. It's bulletproof, that bottle, and you can leave it on the rig, but now you're using water that's going to give you a good reaction.
How do we know that something is soluble? This is going to be kind of a weird question. I'm sure a lot of you guys out there are like, oh, that's pretty easy. But how do you honestly know whether or not, like, you put a sample in something.
A solid.
Is it solid? Right. Like, let's say we take a powder.
Okay.
And we take the powder and we put it in there. And, there's miscible, which we would turn around and be like, okay, yeah, no, definitely. Like, it's all gone. It all dissolved. And then there's the non-soluble where, like, all right, that clearly is not soluble. But there's also, like, an in-between where some of it is soluble, some of it's not soluble.
Yeah.
How do you kind of...
All right, so, and this is be better exemplified in a liquid, but in a solid, you can get a couple different observations. So if we put some in, let's say a test tube, right? Because it's nice and easy, so I can visualize the sideways view of this stuff. I throw it in water, and I kind of observe it before I even move it around. And I'm looking for off-gassing, bubbling, heating, cooling. I'm looking for all types of crap. And now I start to flick it, and I'm starting to actually mix it in. And what I'm looking for is, did it dissolve, or did it float? Did it sink? Is it milky? Is it precipitating back to the floor? Did I change the color? There's a million different observations, but each one of those observations will lead you towards a new classification, identification.
Down the road.
Down the road. We're going in the right direction, though.
Like, all right, I kind of know that we got this.
Yeah, so it's really important to put a little bit of water, maybe a half-inch of water in a test tube, and then throw a little bit of the sample in there, a little bit of the sample, and we see how much dissolves.
Right, because once you do that, besides dissolving, you're also now testing the water reactivity of this product. Keep in mind that water reactive substances are in and of themselves dangerous, but they also produce gases, and the liquid itself can become hazardous. So just make sure that you've got all your stuff on and that you do this properly before you go throwing something in water to test its reactivity.
Hey guys, you've heard us talk about First Line Technologies' Dahlgren Decon solution and their FiberTech wipes and mitts. Well, they've had a lot of their customers ask them to provide in-depth training on using Dahlgren Decon, FiberTech wipes, as well as their various kits, and now they've created a First Line Utilization Academy to deliver the range of classes designed to improve their students' knowledge of hybrid decontamination. They have a special comprehensive Train the Trainer course designed to prepare trainers and hazmat team leaders to return to their organizations and conduct training. The participants in this course will receive a template lesson plan, a presentation they can use to train their teams, and a quick reference book they can use in the field. Now, class size for the Train the Trainer class is limited to 6 to 8 participants, and classes fill up fast, so reserve your desired training date today. They will also conduct customized on-site classes to entire teams to give everybody both classroom instruction and hands-on experience in using Dahlgren Decon and FiberTech wipes for hybrid decontamination. Call the guys at First Line Technology for more information or to register for a class at 703-955-7510 or email them at training@firstlinetech.com. All right, let's pick up where we left off. Right, and so with reactivity, with the word reactivity, we are looking for, does water, universal solvent, have anything to do with whatever chemical we're testing out? And so if you have reactivity, you have either production of heat or removal of heat, endo or exo, right?
Right.
And so that, either one of those things is going to be another clue to do this. So I know the down and dirty way of doing it, and I might have shown this once or twice on the YouTube channel, is to just kind of brush it up against your skin. However, in the first or second episode, we said some of these things get hella hot. And so use a temp gun. Be the smart guy and look for small changes in your temperature. And you're looking for not just one, but you're looking for a few. You're looking for a trend to see if it's going up or down. Now, because of that quantity is so freaking small,
right,
those bumps may be up or down pretty quickly, and they might disappear quickly. There's no mass to hold the heat.
That's true. That's true. So don't be surprised if it goes up and then goes down pretty quick. Once you have everything in the solution, once it's in the water rather, you can go ahead and actually test the pH of the sample. You don't want to do this while it's dry. If you take a pH paper and you dip it in dry powder, it's not going to do much for you. That's because a lot of acids exist in kind of this powder form. Bases not so much. Bases are usually in the liquid form. So if you have a powder, take a little bit, mix it in with the water, test the pH. This pH is going to give you kind of two things. One, if it is water reactive, it often leaves behind a corrosive component in the water, and we can test the pH.
Right. And so also with this pH thing, so we tested the solubility and we've tested the pH, and now if we are rolling away from either towards the acidic or the basic side, we can start ruling out biologicals.
Yes, that's right.
Right? Biologicals are not going to be way off of that pH scale. So let's say outliers 4 to maybe, let's say, an 8.
8, 9.
Maybe 9. If you have anything that's lower than 4 or above 8, you can rule this out as a bio or a white powder, right? Because it's just not going to be there. So when we have this sample, now again, we're using this theoretical test tube, right? We might meter the headspace of that reaction. You never know what kind of information you're going to get with the product. You're going to get something, let's say it's simple as a binary reaction where it's an A plus B equals C. Well, that C might be flammable, again giving us a clue towards where we're driving.
Right. Let's look at calcium carbide.
Calcium carbide.
Plop that in there, measure the headspace. You're going to find that you may have LELs. And I don't know, does acetylene have PID reading? I don't think it does. I think it has a higher. Think it does. So, but you will get carbon monoxide on your electrochemical sensor. So, pulling that stuff off the headspace, phenomenal idea. Also, we want to use, just like we're doing the pH paper, where we want to go ahead and we want to run the solution through the other colorimetric tests as well. Whether it be something like the wastewater classifiers, there's chemical classifiers. These are tests that run about 5 to 6 different categories on them, and now's a really good time to run through them.
Right, and also you can even look at like KI paper, potassium iodide or oxidizer paper, all the same wording. In case anybody gets confused, right? But this can be used with chemicals. So I would even be doing that with that whole water and solid mixture to see, is it an oxidizer? Did it dissolve in the solvent? And I'm reluctant to say that we can also see if the material is, let's say, energetic, right? So we can do, in some kits, they do a flame test to let us know this.
What do you mean by energetic? Like, when you say energetic, what are you looking for? Because, like, I'll feed my kids a Snickers and they're energetic.
No, I'm talking about, like, black powder.
Okay.
Like, mildly explosive. So if you look at, and I'll pull this out, like the Hazmat system. The Hazmat system has 2 different tests in order to find out if it is energetic. So what they have is a cotton swab test and an explosive tool test, which is basically just a tapered rod. And what you do is extremely small quantities of the unknown.
Not spoonfuls.
Not spoonfuls. Very, very small quantities to see if it does deflagrate or detonate, pop, snap. Very specific arcing, if it arcs downward of the flame. That way we're testing this and we're not going to blow ourselves up, because if you let's say you put a teaspoonful into a test tube and you heated this up, now you're creating a bomb, or at least a partially closed bomb.
Right, a boom.
A boom. There you go.
So when we're doing these tests, especially the flame test, there is a possibility that the oxidizer is going to actually make the flame bigger and make the product seem energetic. But if you pull that product out of the flame and it's an oxidizer, it should pretty much stop burning. Oxidizers only support combustion. They don't burn in and of themselves. So that's a good way to determine whether or not something is flammable or an oxidizer if you haven't run it on an oxidizer test yet.
Right, and this actually, let's say we got past these safety stops and we are actually testing some stuff. We can do some flame tests to find out more than if it's just flammable, right? This test can give you an indication that certain elements are comprised in it, right?
Yeah, absolutely. So things like lithium compounds may be like a carmine.
You wrote that in. I don't know.
Yeah, I don't know what carmine is. I think that's a color. All right, but and I don't know what color carmine is. You know what? I bet you the women out there would know what color carmine is. There's probably a strip out there that
it might be.
There might be. All right, but crimson, things that would burn with crimson often contain strontium compounds, and things that are yellow and red often have calcium compounds.
And there's tons yellow sodium compounds. Even trace amounts. A yellow flame is not indicative of a sodium unless it persists and it's not intensified by the addition of sodium chloride to the dry compound. Now, that's just a few. A little bit. There are so many more. There's like an actual entire science out there when it comes to flame spectroscopy, which is kind of what we're diving into a little bit. Yeah, it's really rough.
It's a cool little course.
But this is how a lot of these meters work.
Yeah, like the AP4C.
AP4C, which is by Progen. It literally looks for the color of the flame, and it says, "Oh, okay, that's a sulfur look," and then it'll give you a couple of bars. So it's really cool how it works. Another thing I want to look at: if I'm starting to heat this up, does it melt? And if it melts, does it change color?
What would, like, let's say I had a white powder that didn't melt. What would that kind of lead you towards?
Okay, if it let's say it doesn't even matter the color. If it doesn't melt, then it's going to be probably inorganic.
Okay.
I'll start there, right?
Okay.
So and different things can, let's say, melt and then recrystallize. It can melt and stay liquid. But if it starts changing, like charring,
Okay.
then you're leaning more towards that whole carbon-based thing.
Because it's the carbon-based things that are going to burn, and they're going to leave those char marks behind.
Right.
Ah.
Right. So all these observations can be used to help narrow down what they could be.
Then at the same time, well, not at the same time because you'll actually end up lighting your meter on fire. But if you have a solid, try running a PID over the surface. Give us an indication if it's sublimating or not. And remember, it's only going to tell you if it's sublimating if it's less than a 10.6.
Right. Now, if you have access to a spectral equipment, something like FTIR or Raman, you can also start to get an idea of the makeup of these compounds by just like seriously looking at the spectrum. And a lot of these meters, whatever technology or whatever meter manufacturer does, most of them have a user-based spectrum. They'll put it up on the screen. Not that anybody can read it, but really it's a starting point to get deeper and to really start teasing out these IDs and versus just like classification of that.
Yeah, and this all links together with the observation of things like the color and the look of the solid. Because when you're researching these topics, right, when you're doing an unknown, especially something like a white substance or any kind of solid substance, the results that you get can give you a couple of different choices, right? You could have 10 different choices. And then you turn around to your resource guy and you're like, hey, these are my different options. These are my observations. They turn around and they do the research, and they're going to narrow it down even further because your observations like color and texture may not jive with what that chemical is. So those kinds of observations are really, really important to constantly back test your theories and your hypothesis.
Yeah, and nowadays you have a slew of colorimetric test kits out there that help identify narcotics and drugs, and often these are quick tests and they have a pretty high degree of certainty. Now, I will say one thing. Don't put the colorblind guy on the colorimetrics. He can be the scribe, but if he can't tell the difference between orange and blue and pink and fuchsia and bronzeberry frost and all these other lovely colors, don't put him on. He's not a guy.
Okay, so what if we're talking to a department right now that doesn't have the HazCAD system? They don't have some of the things that we actually are talking about. How can they do a very basic, solid unknown and walk away feeling comfortable with their decision? I mean, is there... I know we've got access to all sorts of stuff, and there's people out there that are like, oh man, I would love to get a HazCAD system, but we can't afford one of those. Like, let's say I had a white powder in the street. What can I do to just kind of get an idea of, whether or not this is an organic or is this a salt, or, it's how do you do that?
Well, you know what, that's one of the problems of, well, it's not a problem. That's one of the reasons why the HazCAD system is so popular, is because it's a system. So it will lead you through just about everything out there, and it's all one-stop shopping. It's all in the box. So like you can figure out if it's flammable, combustible, if it's an explosive, if it's organic salts. It does all that stuff. How do you do on the street? I mean, honestly, if I'm doing this legit, I'm only doing a few tests, and it's like, can it solubilize? Is it off-gassing?
We're really
metering?
just, at that point, you're really just trying to get it into the dot categories, right?
Exactly. I'm just looking to put it on a placard.
So we're looking at explosives, which you can really do with a torch.
Right.
Right? Liquids, if it's a liquid, it's or a gas, then that eliminates those, but you'll know flammability. Water reactive solids, we can kind of do by tossing it in a little bit of water. The oxidizers, we should have a KI test for. Poisons, pick your newest guy and feed it to him. Don't do that. That was a joke. And radioactive, where we're testing for with meters. So
with the meters.
Really even
and
without,
even corrosives, you're even doing the pH.
That's right. You're doing the pH. So, don't think that just because you don't have the ability to kind of really narrow it down that you can't come across something or have the ability to test it to at least categorize it to its most basic category. Well, that wraps up another episode of the Hazmat Guys.
You can find us on Facebook, Twitter, and our YouTube channel at The Hazmat Guys, and take a moment to call our comment hotline at 843-628-1484.
And we are always looking forward to your feedback about information or interesting incidents that you were a part of, so send us a note at feedback@thehazmatguys.com.
Remember, guys, don't just get on the job, get into the job.